In this video, let's go ahead and see if we can strengthen our understanding of one-step equations together. For questions 1 through 4, let's go ahead and see if we can find the correct solution out of the solution set that we're given. So you're going to go ahead and see here that here we have a solution set. We have 4 different possible values that could be the answer to the equation we have here. And we're going to see if we can find the correct one. All right, so basically x is possibly equal to one of these 4 numbers, and we're supposed to find the one that is correct here. If you go ahead and try this -6 first, -4 times -6 is positive 24, so I think we can go ahead and just say we know that one's true. If you thought it was -4, -4 times -4 is 16, so that doesn't work. -4 multiplied by positive 4 is -16, so that doesn't work. And then -4 times positive 6 is going to be -24, so that also doesn't work here. So what you can do here is just choose the one that does work. In this case, I'm going to say this -6 is going to be our solution. So I'm going to go ahead and say here that x does equal -6. This would be our solution. Now, the directions do say to go ahead and substitute the correct solution into the equation and simplify it to verify that it is going to be correct. So let's go ahead and show that. So we have the original equation of -4x is equal to 24. And if you go ahead and substitute in this -6 in for x, it would look like this. It would say -4 is multiplied by this -6, right? And that should be equal to this positive 24. And I think that is true, right? Because -4 times -6 is positive 24. So we're just substituting it in to see that we have a true statement, which is what we have here. 24 does equal 24, so that's good. Let's take a look at another one. For number 2, we have this x minus 9 is equal to -7. If we plug in -16 here, -16 take away 9, that's going to be -25, so that doesn't work here, right? What about -2? Well, -2 minus 9 is going to be -11, so that doesn't work either. If you plug in +2 take away 9 is -7, so this one seems to be our answer, right? So let's go ahead and say this is going to be our solution, and we're going to go ahead and say that x here would be equal to +2. So how do we show that we know this is true, and how do we verify that? Well, we can go ahead and say that we can write our original equation of x minus 9 is equal to -7. And then let's go ahead and substitute in our value here of 2 that we think the answer is. So 2 minus this 9. 2 minus 9, hopefully that makes sense, is going to be -7. So when you can simplify this down and say -7 equals -7, we know that our solution makes sense, that x does equal 2. Let's check out number 3. For number 3, we have the equation x plus 15 is equal to -17. If we try this -32 plus 15, I think that honestly is -17. So I think this one right off the bat is going to be our solution. We don't have to really try the other ones here, but let's go ahead and verify this real quick. So we have this x plus 15 is equal to -17. And again, we're trying to find the number for x that makes this true. Only one of these will work. We think it's -32. So I'm going to plug in -32, substitute that in. Plus 15 is equal to -17. And to verify this, really what you would do on the side is 32 minus 15. So if 32 minus 15 is 17, then this must be true. We can say -17 is equal to -17. So if you want to write it on the side, feel free to do so just to double check to make sure you are correct here. But we can go ahead and say that x does equal -32 here. Okay, so you just have to go ahead and see if you can find the one x value that makes this true. For number 4, we have this equation of y divided by -8 is -7. So let's see, what number divided by a negative number is equal to a negative number? Well, I think that's got to be a positive number, right? If you try -56 divided by -8 is +7, so that's no good. -15 divided by -8, that's not even going to be a nice whole number or an integer, so that's not going to work. 15 is also not going to work. That's just going to be the opposite. And then 56 divided by -8 is -7. So I think that makes sense here. So I'm going to go ahead and say that 56 is going to be our solution. And we'll say here that y is going to equal 56. But let's go ahead and verify that real quick. So our equation here is y divided by -8 is equal to -7. We think this y is going to be equal to 56. So if we substitute in 56, what is 56 divided by -8? 56 divided by -8, I think, is -7, right? Since -7 equals -7, that's a true statement. We know that we did a good job, and y does equal 56. All right, Let's try a few other types of problems now. So in questions 5 through 8, let's go ahead and determine which property of equality, remember there are 4 of them. There's the addition property of equality, subtraction, and multiplication and division. So there's 4 of those properties of equalities, as well as an identity property. So there's 2 of them. There's the identity property of addition and the identity property of multiplication. And so we're going to use one of these properties of equalities and one of these identity properties to solve each of these equations. And we do not need to solve these equations. We're just going ahead and say which properties would we use to solve it. All right, so for number 5, we have this equation of x minus 8 is equal to negative 2. If you wanted to get x alone here, I think we would add 8 to both sides. So if we're adding 8 to both sides, we would go ahead and say that we would be using the addition property of equality. Now, for the property of equality, I usually will go ahead and abbreviate that as POE, okay? So if we were to add 8 to both sides of this equation, you would end up with 0 next to the x. So x plus 0 is just going to be x. Now, if that's the case, we would be using the addition identity property, right? So we can say the identity property of addition, okay? So these would be the 2 properties that we would use to solve this equation. First, we would use that addition property of equality, and then you would use the identity property of addition because we'd have a 0 in that equation. What about number 6? This one, we have y plus 19 is equal to negative 14. So how would you get y alone here? Well, I think the first thing we would do is go ahead and subtract 19 from both sides. So if we do that, that means we're going to use the subtraction property of equality. Now, if you do it on the left side, you got to do it to the right side of the equation. That's that subtraction property of equality. Now, 19 minus 19 would be equal to 0. So that means we would have y plus 0, which is just y. And we don't have to write that 0 anymore if you use the identity property of addition. All right, cool. Moving on to number 7. For number 7, we have this equation of negative 9x is equal to 81. So how are we going to get x alone here? Well, this negative 9 is multiplying by this x. So if we want to change this negative 9 coefficient to a 1, so we have 1x, we're going to have to go ahead and use the division property of equality, right? We would divide both sides by negative 9. Now, if you divide both sides by negative 9, you'd end up with 1x equals negative 9. And if you don't write that 1, because 1x is really just x, then you can go ahead and use the identity property of multiplication, right? Because 1 times anything stays the same. So identity property of multiplication. All right, cool. Hopefully it makes sense. In 5 and 6, you use the identity property of addition because we're adding and subtracting. But in 7 and 8, we're going to be using the identity property of multiplication because we're multiplying and dividing. Okay. In number 8, we have this equation y divided by 4 is equal to 13. So if you want to figure out what y is, you would do the opposite of dividing by 4, the inverse operation. So the inverse of dividing by 4 is going to be multiplying by 4. So let's go ahead and multiply both sides by 4. So if you go to do that, you would be doing using the multiplication property of equality, right? You would multiply both sides by 4. Now, if you do that on the left side, you would see that you'd end up having a 4 over 4, and 4 over 4 is just 1, so you'd have 1y. And if you don't want to write that 1 anymore, you'd be using the identity property of multiplication. For problems 9 through 12, let's go ahead and solve each of these following equations, but let's go ahead and use the justifications that we are given. So for this first one, let's go ahead and write the original equation. That's going to be x plus 18 is equal to negative 14. Okay. It says apply the subtraction property of equality. Okay, so what would we subtract from both sides of the equation? What makes sense? Well, I think what makes sense here is to subtract 18. So if we go ahead and take away 18 from the left side of the equation, then we would have to go ahead and take away 18 from the right side of the equation, right? Now, why would we do that? Well, it says to go ahead and simplify using the additive inverse property and by combining like terms. So on the left side here, keep in mind that this 18 minus 18 is the same thing as 18 plus negative 18. That's the additive inverse property. So you can go ahead and say this would be x plus 0 on the left side of the equation. And then if we combine these constant terms on the right side of the equation, this negative 14 minus 18 is the same thing as negative 14 plus negative 18, and that's negative 32. Finally, let's go ahead and simplify using the identity property of addition. So x plus 0 is really just x, so we can say x must equal negative 32. All right, cool. Let's take a look at number 10. Here we have another equation, but this time we have a different operation. So we have y minus 23 is equal to negative 7. Okay. It says apply the addition property of equality. Okay. Now, what number makes sense to add to both sides of this equation? Well, you can add any number in the world, but what number would be strategic for us? I think we're going to add 23, right? Because the opposite of negative 23 is a positive 23, and that might be nice for us. So let's do that on both sides of the equation. This is using the addition property of equality. Now, it says simplify using the additive inverse property. So this is technically a negative 23 plus a 23. So that's the additive inverse property. We're going to get y plus 0. And then on the right side of the equation, we combine these constant terms or these like terms. Negative 7 plus 23 is going to be 16. Okay. Finally, let's go ahead and simplify using the identity property of addition. So that means that this y plus 0 is really just y. So y must be equal to positive 16. All right, let's check out number 11. For number 11, we have this equation of negative 3x is equal to negative 51. So let's go ahead and just write the original equation. It says to apply the division property of equality. So let's go ahead and take this negative 3x on the left side, and let's go ahead and divide it by the coefficient of negative 3. And then on the right side of the equation, let's take this negative 51, and of course, let's divide by the same number of negative 3. That's using the division property of equality. Okay, so if you take this x and you multiply it by negative 3, but then you divide it by negative 3, that's really just saying that you are having this negative 3 over negative 3. So the first negative 3 looks like this. The second negative 3, if you're dividing it, means you're multiplying it by the reciprocal. So these are multiplicative inverses, right? So this right here, these negative 3s are going to be on top of each other as a fraction, and you would just get 1x, just because negative 3 divided by negative 3 is positive 1. On the right side of the equation, negative 51 divided by negative 3 is going to be positive 17. Okay, so again, this part is probably the more confusing part. This is negative 3x divided by negative 3, so you can write it like this as well. And again, you can see hopefully that this negative 3 divided by negative 3 is that positive 1 that you get over here. So there's a couple ways you can kind of look at that. Then you can see this coefficient of 1 using the identity property of multiplication. You don't need to write that 1. You can just write x is equal to 17 afterwards. Okay, let's try one more of these types. The original equation here is y divided by 8 is equal to negative 6. Okay, not using fraction bars right now for these types of equations, but we will later on. Let's go ahead and apply the multiplication property of equality. That means you're going to multiply both sides by a specific number. So in this case, what number does that make sense to use to get y alone? I think I'm going to go ahead and take this y divided by 8. Let's go ahead and multiply this left side by 8, all right? Because if you take y and then you divide by 8, but then you multiply by 8, something nice will happen there, right? On the other side, let's take this negative 6 and let's also multiply that by 8. All right, so on the left side here, if you really think about this, y divided by 8 is kind of like this. That's right, it's y over 8. And if you multiply by 8, that's 8 over 1. Now think about it, there is an invisible 1 here by the identity property, so you can kind of see that these 8s can cross cancel, and because they're reciprocals, right? 1 over 8 and 8 over 1. So using the multiplicative inverse property, this is just going to be 1y on the left side of the equation, because the 8s can cross cancel to become 1. On the right side of the equation, negative 6 times 8 is going to be negative 48. Using the identity property of multiplication, we can go ahead and drop the 1 and say that y is equal to negative 48. All right, cool. Let's move on. For these last set of problems for 13 through 20, let's go ahead and solve each of these following equations, okay? And make sure we show clear and logical work. Make sure we do use a property of equality. We also use one of the inverse properties, either the additive inverse or the multiplicative inverse property. Then we have to use one of the identity properties, and then finally use substitution to verify that our solution does lead to a true statement, that the left side does equal the right side after we substitute in. All right, so for number 13, we have this y minus 24 is equal to negative 58. The property of equality that makes the most sense here to use is going to be the addition property of equality. I'm going to go ahead and add 24 to both sides of this equation. Looks something like this. Now, if you go ahead and do that, we're going to end up with y plus what? Well, negative 24 plus 24 is going to be 0. And on the right side of the equation, negative 58 plus 24 is going to be negative 34. Okay, so we just went ahead and used a property of equality. Then it says use either the additive inverse property or the multiplicative inverse property. I think we already just used the additive inverse property here, right? Because these are opposites and we got 0. So that's cool too. Then let's go ahead and use an identity property. Well, we are adding here, so the identity property of addition makes sense. So it's going to be y is equal to negative 34. And while this is our solution, let's go ahead and do part 4, which is substitute to verify that our solution does make sense. So let's go ahead and do that on the side here. We think the answer is negative 34. So let's take this negative 34 here and then substitute it in. So minus 24. And let's see, does this equal the negative 58? Well, if you keep change and flip or add the opposite here, negative 34 plus negative 24, like actually think about it, it is negative 58 if you add the two negatives together. So if negative 58 does equal negative 58 and you've thought about it and you verified it, then this must be true. Okay, so we did a good job. These are all checkable. For number 14, let's check this one out. We have x minus 43 is equal to negative 29. Okay, so let's see. If we want to get x alone, we want to move this minus 43. Let's go ahead and add 43, right? Opposites are really good in these particular types of problems. If you go ahead and add 43 to both sides here, you're going to get 0 on the left side. We're going to get x plus 0, right? And on the right side of the equation, negative 29 plus 43, you can also think about that as just what? 43 minus 29. So if you take 43 and then you take away the 29, we're going to end up with 14. Okay. Now, did we use the additive inverse property? We did, because these are opposites, and we got 0. Now, what about the identity property? Well, x plus 0 is just x, so that's using the identity property of addition. And then this right here we think is our solution. Now, let's go ahead and substitute to see if this is true or not. So we think x is 14. Let's go ahead and plug it in. 14 minus, let's see, 43. And let's see if that's equal to this negative 29 on the other side. Okay, so 14 minus 43, keep in mind that's the same thing as 43 minus 14 and just make it negative. And so go ahead and think about that for a moment. And if you think that it is negative 29, because it is, then you did a good job. So definitely think about it just to confirm so you get also a little bit quicker and more fluent with adding and subtracting integers as well. All right. For number 15, we have an equation with multiplication in it. So let's say we have negative 14 times something, or a, is equal to 70. Well, instead of multiplying a by negative 14, let's go ahead and then afterwards divide it by negative 14. I'm going to use a fraction bar to show the division. Okay. What happens when you have a negative 14 on top divided by a negative 14 on bottom? Well, negative 14 over negative 14 is just going to be 1. So we're going to have 1 times a equals. And on the right side, 70 divided by negative 14, well, 70 divided by 14 is 5, so this must be negative 5. So this is the multiplicative inverse property, and you don't have to write any more specific than this, but negative 14 is just negative 14 over 1, and then the negative 14 on bottom is really 1 over negative 14, right? So you can see that these are reciprocals of each other, and if you multiply reciprocals, you always get 1. Then using the identity property of multiplication, you can go ahead and drop the 1 in front and say a equals negative 5. This right here, we think is our solution. But we can check it real quick, right? We can take our original equation, negative 14, and multiply it by this negative 5 and see if it equals the 70 on the other side. All right, so if you go ahead and check this, well, negative times a negative is a positive, so that's good. And then so this is positive 70, I think. And so if that's true, then this might be the right answer. All right. What about for number 16? For number 16, we have a fraction. We have n divided by 9 is equal to negative 46. So let's see. I think what I would do here is rewrite this just because these ones require a little bit of more space. So I think that's a good rule of thumb to follow. So we know n divided by 9 is negative 46. So how do you get rid of that divided by 9? Well, I think what we can do is multiply both sides by 9. Right? If you take n and you divide it by 9, but then you multiply by 9, you would get back to being just 1n or n. So this 9 over here is 9 over 1. And then the n over 9 is just 1n over 9. So you can see the reciprocals here are going to cancel each other out when you multiply and become 1. So using the multiplicative inverse property, we're going to get 1n is equal to, and on the right side of the equation, we have 46 times 9. So you can go ahead and multiply that out. But I think that's going to be negative 414. Okay. If you go ahead and use the finally, if you use the identity property of multiplication, you can drop that 1 and just say n is equal to negative 414. And I think this would be our solution. Okay. Now, how do you check to see if this is true? Well, let's take that negative 414. And if you go ahead and divide that by 9, does that equal the negative 46? Well, I'm not going to go ahead and do the long division right now, but if you were maybe on a quiz or a test and you wanted to double check and you didn't have a calculator, you should definitely do that long division to double check it. But since I'm going over this right now with you, hopefully it makes sense that this should work, right? Unless I did something wrong, but I believe this is correct. Okay, so negative 46 equals negative 46, so n must be negative 414. All right, let's try number 17. For number 17, notice how the variables on the right side of the equation, don't let that bother you, it still is going to work the same. So let's go ahead and see. We have m minus 19, and that's equal to negative 24. If we want m by itself, let's go ahead and use the addition property of equality. Let's add 19 to both sides here. On the left side of the equation, negative 24 plus 19 is the same thing as 24 minus 19, but then make it negative. I think that's going to be negative 5. On the right side of the equation, we have this m, but what happens when you add opposites? Well, that's the additive inverse property, and you're going to get 0 every time. Using the identity property of addition, you can go ahead and drop the 0. And you can also use another reflexive property, which we haven't talked about. It just means you can turn the equation around here, but we can say negative 5 is equal to m, or you can say m is equal to negative 5. So not a big deal. You can write your answer either way, but that's just kind of an extra step to keep the variable on the left side, but it's totally fine to keep it on the right as well. Now, how do you substitute to check? Well, let's take this negative 24 and set that equal to, we think m is negative 5, so take negative 5 and take away 19. We're going to go ahead and see if this is true or not. So keep the negative 24 on the left side, and then negative 5 minus 19 is negative 5 plus negative 19, and that is negative 24. So surprise, surprise, this does work, right? It's good to check. Obviously, these are all working out because we're doing them together here, but you might make some mistakes on your own sometimes, so it's always good to check to make sure. Moving on to number 18, we have 38 is equal to e plus 71. So if we're trying to get this e or figure out what e is, how do you get rid of a plus 71? Well, turns out you would go ahead and use a subtraction property of equality and go ahead and take away 71 from both sides. Now, if you go ahead and take 38 and take away 71, you really could think about that as 38 or 71 minus 38 if you'd like to, and then make it negative. And that should be negative 33 on the left side. If you need to write it out, feel free to do so. On the right side of the equation, we have e, and then what's 71 minus 71, or 71 plus negative 71, right? Those are opposites, so that's the additive inverse property, which gets you 0. Now, using the identity property of addition, you can drop the 0 and just say negative 33 equals e. And then again, you can use that reflexive property and turn this around, but don't worry about that. You can just write it on your own. Don't worry about the property, okay? So e is equal to negative 33. Now, can we check this? Of course, we can check all these equations. So let's take our original equation of 38 is equal to, let's substitute in negative 33 in for e. Let's go ahead and add 71. So let's see here. Let's see if this is true. Well, on the right side here, negative 33 plus 71 is the same thing as 71 minus 33. 71 minus 33 does happen to be 38. So 38 equals 38, which means we did a good job. So this must be true. E does equal negative 33. All right, for number 19, we have decimals here. So notice how we have a multiplication here. We have 0.8 times W And so if we're trying to figure out what W is, we really want to get this coefficient to be 1. So let's go ahead and divide both sides by 0.8. Okay. Now on the left side of the equation, we have a negative divided by a positive. So we have this 11.92, and we have to divide that by 0.8. Now if you go ahead and divide that, you might need to go ahead and pause and do the long division. You should put that on your paper unless you can divide this in your head. And then you should be able to get here, I believe, negative 14.9. And then kind of showing this really clearly on the side, 0.8W is 0.8W over 1. And then when you divide by 0.8, it's really multiplying by 1 over 0.8. So hopefully you can see these reciprocals. So this is using the multiplicative inverse property when you go ahead and say that these multiplied together gets you 1. And so you say that would be 1W. Now, using the identity property of multiplication, you can go ahead and drop that 1 in front of the W and say negative 14.9 equals W. And then you can use that reflexive property and just turn this around. But again, as long as we know that W is equal to negative 14.9, we are good to go. Now, if we want to check this, take this negative 11.92, and then let's set that equal to 0.8 multiplied by, let's see, we think it's negative 14.9. So this one, in terms of checking, you might need to do some extra work on the side here, but you would take the negative 14.9 and multiply that by the 0.8, or you can ignore the negatives if you want. But you should go ahead and multiply that out to verify, just to know for 100% sure you are correct. But this does equal negative 11.92. All right, so that means that W does equal negative 14.9. For this last one, this one's kind of like 16 in terms of it looking like a fraction to start. So again, I like rewriting these so we have extra space here. So negative 8 equals h over 2.4. Okay, so if we're trying to figure out what h is, what are we going to do? Well, we have h divided by 2.4. What if we multiply it by 2.4? There's a lot of dots here. I'm going to use parentheses instead. That's going to be more clear. And let's multiply this by 2.4. Okay, so again, if you take h and you divide it by 2.4, but then you multiply it by 2.4, that's going to look like this. H over 2.4 times 2.4 over 1. Again, this h has a 1 in front of it, so you can see these reciprocals. This is the multiplicative inverse property. You're just going to get 1 here, because 1 over 2.4 times 2.4 over 1 is 1. So on the right side of the equation, we know this is going to be 1h. But on the left side of the equation, we have to multiply here. So you can just go ahead and multiply 24 times 8. 24 times 8 is 192, but move the decimal over to make it 19.2. And it's going to be negative 19.2 just because we have a positive times a negative. Now using the identity property of multiplication, let's drop the 1 and just say negative 19.2 is equal to h. And then you can use that reflexive property again and just turn this around and say h is equal to negative 19.2. All right, cool. So if we want to go ahead and just substitute in just to show that we're checking, negative 8 is equal to, we think h is negative 19.2 divided by what? Divided by 2.4. So we think this is true. Most likely it is true, but we should go ahead and just check it. Again, if you didn't have a calculator, you would definitely go ahead and divide this using long division to double check. 2.4 does fit into negative 19.2, I guess negative 8 times technically. So we can say negative 8 equals negative 8. And so this does work out. H does equal negative 19.2. So there you have a few different practice problems dealing with solving one-step equations. Hopefully you also practiced and really thought about and got the hang of using some of those properties of equalities, as well as the multiplicative and additive inverse properties. And then you also practice using the identity properties at the end there. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.